This is the video introduction to Experiment 6, Potentiometric Acid-Base Titration. The goal of this experiment is going to be to determine two unknowns: the percent of acetic acid in a solution of vinegar and the mass of aspirin in an aspirin tablet. In both cases, this is going to be a strong base, weak acid titration, sodium hydroxide being the strong base, and either the vinegar or the aspirin being your weak acid. The reactions of interest are there. You should notice that the stoichiometry is 1-to-1 for both of them. When you do your standardization, you're going to standardize your sodium hydroxide titrant using phenolphthalein as your indicator, and you're going to titrate KHP with the dilute sodium hydroxide solution. When you analyze your unknowns, you're not going to need an indicator because you're going to be using a pH electrode to find the endpoint. I'm not going to go over the standardization of the titrant again because you've already done that. All you need to know is that you're going to take the 0.1 molar sodium hydroxide that you made in experiment 3. You're going to dilute it by a factor of 2, so it's about 0.05 molar, and then you're going to standardize it to find its exact concentration. Once you've done that, then you move on to the determination of your two unknowns. You're going to come into lab and you should have a pH meter on your bench. And when you turn it on, you should see the words "good electrode" on the screen. If you see that, that means it's standardized and ready to go. If you don't see that, let me or one of the TAs know so we can do that for you. You're also going to have on your bench a stir plate and a really small stir bar. You're going to set up your titration like this with a beaker instead of an Erlenmeyer flask on the stir plate. Your stir bar should be in there. And then you need to arrange the pH electrode and the burette so that they both are over top of the beaker, so that you can lower the pH electrode into the beaker and still be able to drip from the burette into the titration beaker. When you read the pH, so you're going to read the pH after every addition of titrant, and the additions are going to be of different sizes depending on what point of the titration you're in. You know that you can read the pH and record it in your notebook when you see this little note that says "stable" on the screen of the pH meter. The only time this might not happen is when you're close to the endpoint, and I'll leave it to you to figure out why that is. So like I said, this stir bar is really tiny. All the waste for this experiment can go down the sink, but it's very important that you don't dump these stir bars down the sink because they are obviously not soluble in water. So if you'll notice our sinks, all the drains are on the right-hand side. So you should pour your beakers out on the left-hand side so that if the stir bar does come out, you have time to grab it before it goes down the drain. Your data analysis, the standardization is very straightforward. It's just the same thing you did in experiment 3. For your unknown determination, since you now have a titration curve instead of just a volume corresponding to an endpoint, you're going to need to do a little bit of graphing with Microsoft Excel. The data you collect in the lab is going to be in sets of volume and pH data points. And so these are just XY data points, and you're going to plot these at home using Microsoft Excel or something else. In your lab manual online on Blackboard, there is handout 4, and this is going to tell you how to do the 3 ways of data analysis that we're going to use to find the endpoint. The first of these is called the bisection method, the second is the first derivative method, and the third one is the second derivative method. You're going to do all 3 of these, report the results from all 3, and also make a conclusion about which one is the most reliable. Your bisection method data is going to look like this. So this is just the plot. On the x-axis you have titrant volume added, and on the y-axis you have pH. So just plot x versus y in Excel, find the endpoint using the method that's detailed in experiment or in handout 4. I'm not going to go into that here. To plot the first derivative, you're going to need to calculate the columns shown here. So the average volume is the average of 2 data points. Delta V is going to be the difference between the second of those points and the first of those points. So if they're 2 milliliters apart, delta V is going to be 2. If they're 0.2 milliliters apart, it will be 0.2. Delta pH is the change in the pH corresponding to the 2 data points that you average that volume, and then you divide delta pH by delta V, that's what's going to be on your y-axis. The average titrant volume is going to be on your x-axis. So this is, you're taking a first derivative of your data. And then you're going to do essentially that same thing again to find the second derivative and to find the endpoint using that method. In the first derivative plot, the endpoint is the highest point. On the second derivative plot, it's the place where the y-axis, or the x-axis rather, is crossed by the line. There's going to be a point above and a point below. You'll be able to draw a line between them, so in this case it's about 27 milliliters. You're going to need to turn in all three of these plots with your lab report, so make sure that you understand how to plot all these, how to read them and get an endpoint, and make sure that you